Hey everyone, welcome back to another video. Today we're going to be doing a mock system design interview with a Netflix software engineer here, Uma. Uma, would you like to tell the channel a little bit about yourself before we get started?
Yes, absolutely. My name is Uma. I am currently a software engineer at Netflix. Prior to that, I was a software engineer at Microsoft for around 5 years. I am also a creator. I make videos online about programming, everything related to the tech career, and also the technical interviewing process. So yeah, happy to be here. Thanks for having me.
Okay, happy to be here too. And yeah, I'm gonna have his channel linked below in the description for you guys to check him out as well. You should really. But yeah, so let's dive right into the interview. You have Excalibur open, right?
Yes.
Okay, so today we're gonna be designing a video streaming platform like YouTube.
Okay. So the question is to design a video streaming platform like YouTube. Okay. So I want to start by getting some requirements from you. YouTube is a huge platform. What exactly do we want to design specifically within YouTube? There's multiple users, multiple things happening. Is there any part you want me to focus on?
Okay. For now, I'd like to focus on the part where people can upload videos, the
Okay.
part where people can view videos,
Okay.
and search
Okay.
for videos. Yeah.
And then 3, users can search for videos. Okay. So users can upload videos, users can view videos, and users can search for videos. Okay.
Yeah.
As it relates to uploading, give me one sec. I'm thinking through these requirements to see if there's any follow-up questions I have.
No problem.
So upload the videos to YouTube, something like YouTube at least. Users can view the videos, so stream the videos that have been uploaded. Users can search for the videos. Are there any limitations to who can view what videos, or is it more like an open public network similar to what YouTube is now, where as far as the video is public, anyone can view it?
Yeah. As far as the video is public, anybody can view.
Okay. So I'm guessing we don't want to do anything related to the so we don't want to do anything related to sharing videos with one person. Like say I share with you and then only you can watch that video. It's just straight up, okay, you can call. Okay, that makes sense.
I think.
Be functional. Yeah, go ahead.
Well, I think for the purpose of this interview, we can focus on everybody can view the video rather than. I know
Okay.
we're talking
Once
about
you press
unlisted.
upload, everybody can view it.
Yeah.
Okay. Do we want to track any metrics or that's beyond the scope of this?
That's beyond the scope of this video.
Okay, sounds good. So functional requirements make sense. Let's go to the non-functional requirements. So I had asked a question regarding whether we wanted to limit the size of the videos, right? So it's a video uploading platform. So how much do we want to, as part of the non-functional requirements, thinking through the scale of how much, how many videos and how much the system can handle? Do we want to add any limitations there, or are users allowed to upload anything?
Let's assume the max length of a video is an hour and 30 minutes.
Okay. Do we want to do max length or max size of the file, if that makes sense? Because you could have a 2-minute video that's 40 gigabytes if it's like encoded the wrong way.
Let's say I'm pretty sure we can go around YouTube's requirement is about 256 gigabytes.
Okay, sounds good. So max length of video, so 256 gigabytes. Okay. I'm thinking through other functional, non-functional requirements. So how many users do we want the system to support?
I think we can assume about 10 million daily active users.
Okay, that's a lot. Okay, 10 million users. Okay, the next. Okay. Do we have any requirements for how fast we want those streams to happen?
Not specifically, but we would like to minimize latency as much as possible.
Okay. Minimize latency. Well, okay, that sounds good. I'm going to go ahead and go on to the high level design if these functional requirements, if these requirements look good.
Yep, looks good.
Okay, sounds good. So for my high level design, I'm thinking of the system from two personas. So the first is the user who can upload the video, and then next is the user who can stream the videos, right? So let's start with the first functional requirement, which is users who can upload. So I'll start with having the user here on a very simple flow. They can connect to our backend server. That this is assuming they have an account, they've signed up. That's beyond the scope of this, but we'll have a system that handles uploading of their video, right? So call it upload, so video upload service. And then the video upload service will, as of now, just take care of the connection between the user that is uploading the video, and then we now need to send that video to two places. First is we need storage blob, which we can use whatever blob storage. It could be S3, it could be Azure storage blob, but we need a blob to store the actual video itself, but we also need a database to store the metadata for that video. So yeah, I'm thinking through what kind of database would be best for this. So there's two options. There's the relational and non-relational. So thinking through what we want to store. We won't have any complex queries. Just going based off this, we'll actually be doing a lot more updates in terms of, let me see, maybe potentially updating views and updating metadata for the video. So I'll go with a NoSQL database here. We can use something like Cassandra that's good for point query, where if you know exactly what it is you're looking for, you can pick it, update it. So let's say DB, maybe so NoSQL DB. We do lose some functionality here in that searching, but we can optimize for that later when we get to that position. So as of right now, the flow that I have is the user will start here, connect to our upload service that'll upload the video to storage blob, and then at the same time we'll upload our metadata for the video, things like the name of the let's say video. So we'll do like the title of the video, how long the video is, size of the video, and all the other stuff that comes along with the video for now. So it's just a small example. Does the upload flow make sense? Yeah.
Okay, you said, user will query the video upload service, which will then put into the blob storage will be the actual video itself.
Yes.
Okay.
Yes.
And then in NoSQL DB, we have the video metadata.
Yes. Okay, let me clarify that. Good point. So for metadata, and then blob storage for video file. Okay. Yeah.
You mentioned you're choosing NoSQL, but you know that we're gonna lose something to do with search. We're gonna lose as much functionality with search. Could you tell me why you made that trade-off?
Yeah, so I'm thinking of search as query, and they're not actually the exact same thing. So
Oh,
Yeah.
okay. Search. Oh, it's query.
Yeah,
Okay.
but yeah, so I mean, you can still query a NoSQL database. It just wouldn't be as optimized as a SQL database. But at the same time, thinking through what I'm designing for, we won't need any complex joins, right? We won't need anything. So
Yeah.
we could just query based on, the video title or stuff like that, like you said, where users can search for the video. So yeah.
Yep. Okay. Makes sense. Thank you.
All right. Does that flow make sense?
Yep.
Okay.
Okay.
All right. Next, I'll move on to the part where users can view videos. So here, there's a separate service to handle the uploading. The viewing stroke streaming service will be different. So I want that to, so it could be the same user here that would go through the, call it streaming service, service. And what that would look like would be, you go to your homepage and then it pulls a list of videos for you. And then the moment you click one, you connect to the service that is the streaming service that then pulls that video directly from the storage block. This is a very simple scenario. There's definitely ways to optimize this, but in the simplest use case, the user will, let me modify these. Okay, I was looking for a double arrow, but I'm not seeing it. But arrowheads, yes. So something like this, yeah, where it would go back to the, you get the blob or the file, right? Simplest, and you have like a media player on the mobile app that's then, getting the bits and the streaming from here and then taking it to the user, and the user is then watching it. That's the simplest format of this. Does this flow make sense? Does this aspect make sense?
Okay. Yeah. At a high level, this will make sense. Yeah.
Okay. I haven't started making optimizations yet. I'm just thinking through the simplest form before we start making optimizations. So users can search video. So I'm thinking through the search here, where thinking through how that would work. That would work on the homepage of whatever application that we're building. But thinking through how that would work on the back end, we can query this NoSQL database that has the metadata, like the title of the video and all that stuff for our search. So maybe I pull this here, and then there would be some sort of relationship. There will be some sort of process where the second on the client side, right, you search for videos. This will return a list of potential videos that you could watch, right, based on those metadata. And then once you figure out what video you want to watch, you click on it, and then it connects you with the streaming service that then goes and pulls it from the blob and then gives you back that video. Does that part make sense?
Yep, makes sense.
So upload. For all of these, the method of communication between these services would mostly be REST, simple GET request, post for uploading, but we can definitely make it slightly more efficient. And then the streaming service, there's different protocols that can be used. I'm not privy to the one specifically that YouTube uses, but there's thinking WebSockets, but that's not how it works. I know 100% sure. It uses some version of that keeps the connection open, and you have to check the bit rate of the video, how fast the internet connection is. You then determine whether you up the bit rate, reduce the bit rate, and all that stuff. So all of that will happen within the streaming service as it's pulling that information from the storage blob. Does that part make sense? Is that clear?
Okay. Yeah. Yeah, it makes sense. Yeah.
Okay. So functional requirements are done. There's definitely some optimizations we can make here where as we lean into the non-functional requirements. So the max length of the video can be 256 gigabytes, right? There's multiple ways we can do this. So first is we I suggest having a separate service that takes care of not just, so I'm thinking of video encoding because, just because the maximum length of a video can be 260 gigabytes doesn't mean we want to store every video at 256 gigabytes. So we need a way for us to compress or encode the video in our own format that still keeps the quality, but reduces the size of the file. That way we don't have, an outrageous amount of, rather we don't have a huge blob storage bill. So before, as we're uploading, I would make a modification here where the user uploads the video to this upload service, but we have a separate encoding service here. Service. And as part of the upload, that video is encoded before it's then sent to the storage blob, right? So the video upload service will also check the initial file, like the initial size of the file that you're uploading, to make sure it's not outrageously big. It's under 256 gigabytes, but it'll also encode the video and upload it to the blob. That way there's a smaller version of the file. So that's the simplest format for how this would work. So I think that would take care of the max length of 256 gigabytes. Do you have any questions there?
Okay. You mentioned we're first going to query the upload service via REST, right? And this will hold the file. Then in this video upload service, you then check the size of the file before moving into the video encoding service.
Yes.
Then get stored in the blob storage.
Yes.
Okay.
And then we encode the video and then we put it in some sort of blob storage. Yeah.
Okay. Yeah, makes sense.
Okay. Moving to 10 million daily active users. That's going to be huge. So I'm going to think about some assumptions here. So the second we have that amount of users, first, the way I've designed this is to use distributed systems. So each one of these is a service that can work on its own using information from upstream services and like downstream services, for example. So we can have multiple instances of our video upload service and deploy to different regions. And then wherever you are, we can have a load balancer or an API proxy that connects you to the right service. So let me just clean this up slightly. All right, so we'll have a proxy service here that will act as both the proxy and balancer. Proxy, and then API proxy. API proxy. Load balancer. Okay. And that'll then connect to the appropriate service. Here, if you're streaming, a similar process will also happen. Oh. So it connects to this guy, the user can upload from here, and then the streaming will also go through here, right? So that way we'll now have multiple instances of this service. Of this one as well, multiple instances. Instances here as well. So our video encode service too will be more like a worker, if anything, that basically just listens for jobs. So we could have a queue here actually. That would make sense. Because being on YouTube, I'm pretty sure the way it works is you upload your video, it starts encoding it, but if a lot of people are uploading at the same time, then you do have to wait for it to do its checks and all that stuff. So this will be a queue where we send to this, and then we have multiple workers. So that way, we can scale each one of these independently. We can have multiple workers working based on how many videos need to be encoded for our queue. Same thing here with our streaming service, multiple instances in multiple regions, and that should take care of the 10 million daily active users. I think also splitting the streaming service from the video upload service makes sense here as well, mainly because I'm going to make the assumption that there'll be more people streaming than more people uploading videos. So having them separately here separates that concern. Does that aspect make sense for the 10 million daily active users?
Yeah, horizontally scaling here will definitely help with handling 10 million daily active users. But my question would be, you mentioned having a queue between the video upload service and the video encoding service. Do you believe we should have a queue between the proxy and the video upload service too, or not?
That's a good question. So, a queue between the API proxy and the uploader service. So, thinking through how it would work. So the queue basically handles jobs, right? So in this case, the job is to go and encode the videos that is being sent here. So maybe this may not necessarily be the perfect representation of this, but the idea here is that the video is uploaded, then you encode it, right? If that makes sense. So maybe I still put a line here between this and this. Oh, not the shape I want to use, but it works, right? So the video is uploaded first before it's encoded, right? If you encode while you're uploading, it'll take way longer time, right? Yes. So the queue here is to say, okay, so upload to this blob storage. As soon as you're done, send a message to these workers to go and encode this video here, to go and do whatever we'll basically do to make sure it's smaller, to make sure do whatever checks, right? Since we're designing something like YouTube, it could be copyright checks for music and all that stuff, right? So all of that will happen here. Now adding that queue here to this service, I don't think it would make sense because it's going directly from the user's application, from the user's device, right? It could be their laptop, it could be their phone, directly to this server that's then connecting here. There's other ways that we can make this more efficient, where instead of going to this service, say the service is bombarded, we can create a pre-signed URL for uploading the blob and upload directly to the blob via a pre-signed URL. That does come with its own challenges as well, because the second we do that, if something fails in the middle of uploading, right, we have to find a way to keep track of. We basically need to have a different service to keep track of that failure and figure out a way to restart, as opposed to here, if it fails in our video service, in our video upload service, it's something that we already have. So
okay,
I don't think using a queue here would make sense, but there are definitely other ways that we can make the uploading aspect a lot more smoother, like I mentioned.
Okay, I understand. Thank you for explaining your reasoning.
Yeah, for sure. Finally, minimize latency while streaming. So right now, for our streaming service, the user is coming directly, they search for a video, they see a video on their homepage, they click, and then we go and then we get the blob, the video itself, and then we send it to them. Think here, right now we have multiple instances. The question is, where are they streaming from? To minimize the latency for them, we need to get the video as close to them as possible. If I'm here in US and you're in Ireland, I believe, right? There is no reason for me or you to be streaming from the same source. So for that, I would use some sort of distributed storage, like CDNs, for example, where there's some system that makes sure the data within the blobs, right, our main source of truth for the video, and the CDNs are in sync, right? We don't want to keep, if there's any changes to the video, we want to make sure that the videos in the CDNs are updated as well. So that's one of the drawbacks to using CDNs, because now you have like duplicated data, but the data here gets to the clients much faster. So we need to figure out a proper time to leave policy for the entries in our CDNs. So that way, we're not saving stale videos or whenever a user uploads videos. Yeah, that would hopefully minimize latency for videos for users who are streaming regardless of where they are from. But it would incur costs. CDNs are not cheap, and depending on who you get it from, you can pay an arm and a leg. So, yeah.
Okay, well, you shouldn't worry about budget for the purposes. If you don't worry.
Okay. Yeah. Let me look through the design one more time and the functional requirement, the requirements one more time in the design. So users can upload videos. Yes, the user goes here to our video upload service, and then it'll go to the blob storage first and then send a message to this queue to encode the videos. Users can view the videos. So have a separate streaming service that connects to CDN, but initially was the blob. So that way the users can stream the video directly to their device. Users can search for videos. So there's here, the search that we'll do would be directly in our NoSQL database. There's ways we can optimize this. But I think this would work, or as a crude, simple base case, except if you want us to dive deep into the search aspect. For the non-functional requirements, the maximum length of the video is 256 gigabytes. As part of our uploading, we'll check for that, but we'll also make sure we don't run out of storage, or we're smart with our storage. We'll also have a separate service to encode the videos to a smaller size, maybe a lower resolution. 10 million daily active users. We'll have multiple instances of our service handling all the load, and a load balancer and API proxy will determine where certain requests from users go. That way we can serve the load evenly. And finally, minimize latency while streaming. We have our CDNs here, which would connect to the storage, and we'll have a system here to keep track, or at least have parity between our blob storage and our CDNs. And it's important for us to also make sure the data in the CDN gets updated in due time. So if a video changes and all that other information. So yeah, that's the design so far.
Okay, you mentioned a time to live in the CDN. Could you talk to me how that would look, and as well as how would you what would you prioritize putting into the CDN?
Yeah, so I mentioned time to live, but time to live is basically an expiration policy, right? So time to live is one of them. Maybe time to live may not actually even work properly here, but yes, the word I should have used is expiration policy. But the idea is, what if the user deletes the video from blob storage from their account, right? Video no longer in their account, but that video is still streamable, for lack of a better way of putting it, right? So the idea is having some sort of mechanism to make sure the state of the video in our blob storage and in our metadata is kept in sync with the data in the CDNs, right? And again, depending on how often that updates, we may find ourselves updating the CDN so much that maybe we consider whether it's worth it or not, right? So that's the trade-off there. But what it will help us with, for sure, is minimizing the latency while streaming. The video is also encoded as well, so we're not sending the biggest raw version of the file to the client. So we'll use, like I mentioned, some sort of streaming, a way to figure out what the client's internet connection is able to handle, and then send the appropriate bit rate for that video. So that's what I meant by the time to live policy. So it's more of a making sure we have a proper expiration policy, because whenever you bring in external systems or anything to help with latency, things like CDNs, things like caching, for example, you have to think about the expiration policy. Yeah.
Okay, that makes sense. But how would we make sure that the CDN does have up to date metadata and video files?
Yeah, a separate system would probably be used for that. Let me see if I can draw that out here. So right now I have it as one arrow, but it could be a service that runs on having a service probably wouldn't make sense. So I was thinking a service, but if we have a service, it would run on a job on some sort of schedule. That wouldn't make sense. So I think instead what we want to do is have some sort of a webhook where the second we have, well, maybe, no, not maybe, we still have a service that listens to, changes to, I don't know, it's giving me this error. Okay, we still have a service that listens to changes to the video states in the blob storage. Is it deleted, or the video states in our metadata database? And what happens here is, instead of it reacting based on a schedule, say checking every hour, it'll be a webhook where the second something happens, it's like subscribed to an event that happens, where a video is deleted, a video is modified, and this service will then take effect and then go do what it needs to in our CDN. If that makes sense.
Okay. Yeah. Makes sense. That would. All right. Yeah. What I was gonna ask, in terms of the video viewing flow.
Yeah.
Could you go a bit more into how you would process different internet connections with YouTube, with videos and video playback, things like that?
Process different internet connections. So are you talking about the playback experience?
Yeah, video playback experience, yeah.
Okay. So the video playback experience for different connections, that's interesting. So I think a lot of that, if I was to design this, a good amount of that will happen on the client side, where the playback experience from the storage blobs, right, from the stream that you're receiving, right, is based on the internet or their internet speed, and then there'll be some sort of communication. I believe the way it works actually is there's some sort of communication between the user's client device and the server, and with each packet with each data packet, video bits and stuff like that the streaming service is sending to the client is telling the server as whether it's able to handle it, right? Whether it needs to throttle down, whether it needs to serve more. That's why sometimes when you start your stream on YouTube or whatever application, it starts you off on the lowest, right? 240 this thing, or 720p, and then over time, as you watch, once your internet connection gets better, it then bumps you up to 1080, and then it bumps you up to like 4K, and then 4K UHD, and then all that stuff. So all of that is happening between our server and the client service that's handling the playback to tell the service to say, yes, send more packets, or send a clearer version. I'm not 1,000% sure how that works inside it, right? But I know on a high level, there's a communication between those two components.
Okay, that makes sense.
Yeah.
Now, what would you say are the biggest bottlenecks in this system right here? Or if there is.
So biggest bottlenecks. So the streaming service, our streaming is going through one service, and it's pulling from the CDNs. There's a potential to stream directly from the CDNs instead of going through our streaming service. So this is one bottleneck. If this goes down, there's no reason why we shouldn't be able to get that data directly from the CDNs instead of going through the streaming service. So that's one of the bottlenecks I can think of. Let me see other ones. It's a distributed systems. Sorry, it's a distributed system. So there are upstream services, downstream services. Thinking through, if one of these goes down, what is going to stop the flow, right? Can any one of these services can stop the processing in their individual flows, but none of them can stop the entire system. So users can upload. Say users can't upload, users can still stream uploaded videos. Similarly, when users can't stream, users can still upload videos. Not sure what that would be useful for if they can't watch those videos, but at least those two flows are separated. Our video encoding service as well. Yeah, there's multiple workers here that are working to encode the videos. If that goes down, the videos are still in the blob storage, so we can still stream that to the users. Probably not be the most efficient way for us, but that also works. So yeah, those are the bottlenecks that I can think of. Just the streaming service. Maybe we can do it directly to the CDN, but otherwise, I've designed it in a way where the flows are not like one flow can't stop the whole system from working.
Okay. So it's time. So it's kind of like we have a microservice architecture here. So
Yeah.
if one goes down, we can still use other services. And you said there's some bottlenecks there with the CDN and the streaming service. How would you tackle that bottleneck then?
Yeah. I would enable the user to stream directly from the CDN, right? That's one way to do it. Sorry, so weird. Okay. Yeah. To pull the data directly. So maybe instead of the streaming service pulling it, this can get a pre-signed URL, generate a pre-signed URL so that the user can stream directly from the CDN itself. So that's how I would tackle that.
Okay. And what exactly are we storing in CDN? Are we storing the full the highest quality of the video, or
yeah, we'll store the encoded version of the video from the blob storage.
Okay.
Yeah.
Okay. And you mentioned with the video upload service, we have a queue between that and the video encoding service. What sort of queuing system or what sort of queuing framework would you use? I don't know what's called, but would you use here and why?
That's a good question. So the idea is it's kind of like jobs that need to be done. So like a producer consumer type of system where the video upload service is producing these events for jobs that need to be done, that need to be encoded here. And then the video encoding service is the consumer that's consuming those jobs and then spinning up workers to go do that work. So these are like multiple workers to go kind of like get the job done, for lack of a better way of putting it, of encoding the video. So that's how I would do it. And the idea is you could have jobs in the queue, right? If you don't have enough workers to go pick them up, it's okay. Once the previous workers are done, then they'll go pick up the new job. So that's the idea of the queue. Now here, like you can, as far as the queuing mechanism you can use, there's multiple ways you can design it. There are multiple industry ones that you can use, but yeah, that's the general idea.
Yeah. So I get the idea. When I'm thinking more on like specific, what industry queuing system would you use here if you were to build this today?
So it's a publisher consumer service. So there's Event Bus, Event Grid. You can do something similar to SQS, like AWS SQS, but what would happen there is you would just have multiple functions or multiple nodes on the other side reading, and then they pick it up, and then if there's a problem, they write it back to a dead letter queue to go alert saying, we can't encode this video. But yeah, there's different solutions, the different queuing services on different cloud platforms like Azure Event Bus, Azure Event Grid, AWS SQS. I'm sure Google Cloud has their own. Yeah.
Okay. Yeah, there is a lot of different. There is a lot of different ones. Amazon, a lot of places have one, but you mentioned you're more leaning towards SQS.
I said that's one option.
That's just
right?
one option. Okay.
So in like the general concept I have in my head is what I've described, where you
Yeah.
have producers and consumers, right?
Mm-hmm.
As far as which one is best for this, I can't tell you, oh, I'll directly pick this one because I don't, how do I put it? It's not, I know the concept exists. I don't know which one would be best for this use case,
Okay.
right? So I can tell you this, but in reality, a different queuing system would work perfectly fine. But I know the architecture or the pattern for solving this problem would be using some sort of queuing producer consumer worker jobs mechanism. Yeah.
Okay, that's fine. Thank you.
Yeah.
And how would we right now we have our NoSQL database and we have our blob storage. How would we scale these?
Horizontal scaling as well. So distributed, so multiple nodes of the same data being stored across multiple places, multiple regions. That'll create additional complexity where we now have to think about data consistency versus the availability of the data. So that's how I would scale it. In this case, I would optimize for, on the CDNs, I would optimize for availability on the CDNs and the blobs, because we want the system to be up and allowing users to stream videos, even if the videos are not the most up-to-date videos. So yeah, while one version of the video is being uploaded across multiple nodes, will optimize for the system being available there, rather than it being consistent.
Okay. Okay. All right. That makes sense for scaling the databases. But now, how would we handle something like where we have these YouTubers, Mr. Beast, where he specifically gets watched a lot more than other people.
Mm-hmm.
How would we handle that in our system?
So one video being watched a lot more than a bunch of other videos.
Yeah.
That's a good point. So that's a good question. My idea here would be, so not every single video is going to go to the CDN. Thinking through it, it might make sense for some of them, the not so popular ones, to just go directly from the blob storage, right? The CDNs could be for the most popular ones. So once we figure out the videos that are picking up, we pull that in the CDN. That way, we optimize for that video, right? So I guess a better question could be, what are we trying to optimize for those people? Like, do we want their videos to, or do we want a good viewing experience for those popular YouTubers? Is that what we're trying to optimize, or are we trying to optimize for something else?
I guess more what I was thinking more of is the fact that that specific YouTuber or video is going to be hit a lot of times. Thing. So like, how do we fix that issue of how we fix that kind of, not exactly a bottleneck, but because you like, do you know what I'm saying, or do I need to go?
I get it, but in the context of designing for systems like that, unless we're performing actions on the video where we're updating it, right? So, for example, maybe updating the metadata for the video could be tricky because we're writing, like, every time someone streams a video, we go and we update the number of views, we update the likes, right? All that stuff. Updating that could be tricky because it's happening so much. But for the streaming aspect of the video, where, hey, this video is in a CDN, right? CDNs are optimized for stuff like that's literally why they're there, right? Where millions of people can go pick up this video and then watch it a billion times, right? So,
okay.
Yeah, the optimization part would be on the updating the metadata for the video, which I'm thinking through how we could do it. Maybe we can do it in terms of like batching. Instead of writing every single time, there's like a like, we could. I've actually heard of scenarios where like the number of views or the number of like likes or in the video is like it's not updated in real time, if that makes sense. So it's stored, and then over time, right, it then kind of like, there's a system that goes back and does the counting or counts whatever events that's happening for the updating, and then update it over time, as opposed to doing it in real time for like smaller videos. Yeah.
Okay, that makes sense. And I feel like you're already handling um, that whole more popular videos being, by saying you said you're going to prioritize more popular videos in the CDNs. So
Yeah.
then that will then put less weight on the actual blob storage itself. So I
Yeah.
guess that
Yep.
does help it
Yeah.
for sure. But now I'm just thinking more of like failover mechanisms. Like what would happen if a whole region was to go down here?
A failover, all the traffic would be transferred to the next closest region. That's, let me think through it. Yeah. So the data is also distributed across multiple regions. The services are distributed across multiple regions. Yeah. If a failover happened,
Yeah.
it'll be catastrophic if we're only available in that region. But since we're multi-region, I think it'll handle it.
Okay. All right. All right. I'm just gonna look through a little bit here. Just make sure I don't have any more questions. I'll ask you all your service running and okay. This is okay. All right. All right. Okay. Makes sense. I think that we've reached time. So yeah. Okay. Thank you for getting on here, Uma.
Yeah.
I
Sounds
will
good.
be in touch in the next few weeks to see if you got the job. Yeah. So
Thank you.
yeah.
Thank you.
Thank you for getting on this. Thank you for getting on the channel. And so now, I'm sure a lot of people watching this video have some questions for you, and seeing as you're working in such a huge tech company like Netflix. And my question for you is like, what is the advice you'd give to people that are preparing for system design interviews now?
I think like it's a lot of practice, right? Practice, but practice the patterns, and like note that, for example, right, you asked me design a YouTube streaming platform, right? And you wanted to focus on upload, view, and search. I could get the same question, but someone could help to ask me to optimize for some, like the functional requirements could be something completely different, right? So it's important to not just like practice the most popular aspects, but understand the patterns in like certain areas, if that makes sense. So also not just spit out things because they matter, like talk through your reasoning. Every time I said something, I gave my reasoning why, like I thought through it in person, like in real time, and I gave my reasoning why we should do that thing, but I also gave the caveat, right? So system design interviews it's never just, oh, we'll put this thing here and we'll put that thing there. Nah. Like, why are you putting it there? What's the trade-off? What else could we put there? Right? What are some optimizations we could make? So you're essentially you're defending your answers, for lack of a better way of putting it, right? You're saying, this is why I think it'll be there, but I know this is the trade-off that comes in there, right? If it's to like design like a regular system, everyone can design it, right? It's saying why your design makes sense, right? And there were instances where I had to push back, where you're like, oh, how would this thing work, right? Because of my knowledge of CDNs and like the research and the stuff that I've done, I know that's how that thing works, right? And so it could be that you were actually looking for something else. So I prompted you, rather, not prompt. I dug deeper to understand what you were actually looking for in your question, as opposed to just answering anything, right? So it's important to understand what the interviewer is looking for, as opposed to just going for, because you, for a lot of the questions that you had, you kind of knew what you were looking for, right? It was my job to figure out what that was and made sure that my answer or my representation of my design met your specific criteria.
Yeah, pretty solid advice there, honestly. And yeah, I've seen going throughout this whole interview that you were explaining why you were putting things down.
Mm-hmm.
That's one of it's genuinely one of the most number one things that interviewers are looking for in system design interviews. Why you're putting things down, the fact that you understand the difference between putting one thing down and another thing down. And yeah, that's a great job. Thank you so much.
Yeah, for sure.
Yeah.
Absolutely.
All right, guys. Peace out.